Imagine that you're visiting a new city for the first time. Let's say you might be new to Raleigh. I know we got a lot of locals here, but I also met some folks that are visiting Raleigh for the first time. You go into a coffee shop and you're thinking, I might want to ask them what they recommend to eat around here. So you ask the attendant, hey, what do you recommend? And they say, I don't know, I just make coffee. You ask, you get an answer, that's a chatbot. Now imagine there's a concierge instead. Same question, but now they have access to additional resources and tools. Say they pull out their phone, they see what's nearby, they are cross-referencing reviews from authentic voices on Reddit or Yelp, Google reviews, and they also remember that you like outdoor seating. And they book you a table at the Thai place 2 blocks away. That's an agent. That doesn't just answer, it reasons, it picks the right tools, and most importantly, it gets the job done. Now here's the problem. You want to build something like that concierge. And so you pick a framework, you spend a day learning it, you get a demo working, and it's beautiful. And then your PM says, can we swap the model? Can we add a tool that calls our internal API? Or why did the agent do that? And suddenly you're not building your product anymore, you're fighting the framework. I've been there, and teams at Amazon have been there, and today I'm going to show you the way out. I'm Jonathan, and I'm a developer advocate at AWS, and in the next 30 minutes, you're going to see me build an AI agent from scratch, add tools to it, and show you exactly what's happening at every step. And the code that powers it, we could probably fit it on a sticky note. Let's talk about what building agents actually looks like today. Step 1, you pick your approach. Maybe it's a framework that you spend some time learning, its unique mechanisms, syntax, etc., or maybe you go and do it yourself. I've talked to some folks today that are just doing straight raw API calls to run inference on large language models. Your own loop, your own glue code. Step 2, you build a demo, it works. You're excited, you show the team. Step 3, your requirements change. Remember that PM, they are looking to use a different model or add a custom tool for that internal API, or perhaps the model provider changes their API. Step 4, you rewrite, you picked a framework. The abstraction that made the demo easy now makes the change hard. If you went do it yourself, you're rebuilding that glue from scratch. Either way, you're now distracted from that business outcome and that product and getting all tied up in the tech implementation itself. Step 5, something goes wrong in production. The agent chooses path A and you were expecting path B. Why? You're reading logs that tell you nothing. It's a black box, whether that the framework internal or your own messy code that you scrambled together to ship on this PM deadline. And you repeat this for every project, every time you switch around. The pace of AI is moving quickly, so we're seeing new models launching with extraordinary capabilities from various different providers. So some of you picked the framework, some of you said, forget it, I'll just call the API directly, I'll write my own loop. Either way, you might hit that same wall where requirements are changing and you're rewriting things. So something breaks and you can't see why. You get to production and realize your demo doesn't survive real users. There's a better way, and you're going to see it live in action. So oftentimes getting started with any kind of simple agent can be the easy part. Every framework or even a simple API call to run inference can get you to that demo. The hard part is what comes next. And I'm going to keep it real with you today. I'm going to show you everything I'm coding up today, and we're going to live demo, is some of the most basic foundations for working with Strands agents. And I want to emphasize the production level readiness here. So I'll tell you that story. Teams inside Amazon were hitting these same walls. We were building production services that were powered by AI agents, some of which you may be using today. And the teams building them kept running into the same problems. The orchestration frameworks they were using were actually getting in the way of what modern LLMs could do naturally. So back in 2023, early 2023, the teams were realizing this. And I think around that time, or maybe just a drop before, like December 2022, the original React paper dropped. And that's React, R-E-A-C-T, reasoning and acting, not the JavaScript framework. These teams realized LLMs could reason, plan, and select their own tools. But the frameworks of that era required complex prompt instructions, custom parsers, orchestration logic. Just getting the LLM to produce valid JSON could sometimes be a problem. It took months to get an agent production ready. And then the models got dramatically better. I'm talking about native tool use, native reasoning, but the frameworks didn't evolve with them. The abstractions that were necessary for earlier models were now overhead for some of these latest state-of-the-art models being shipped by companies like Anthropic and OpenAI. Teams were fighting the framework instead of leveraging the model. So at Amazon, we built something new internally, a model-driven SDK that trusts the model to drive its own behavior. Where it used to take months to ship an agent is now taking weeks, sometimes as little as days. The success is why we open sourced Strands agents. The same foundation running production workloads at Amazon, now yours. And the community showed up. So we have thousands of GitHub stars, hundreds of thousands of downloads for Strands, and contributions from Anthropic, Meta, OpenAI. So this isn't just an AWS thing, it's an open source thing. Let me show you what model-driven actually means. Here's what happens when you call your agent. Your input goes in, the model reads it and reasons what to do. What am I trying to accomplish? What information do I need? Which tools would be most effective? If it needs information, it acts. Maybe it calls a tool, let's say a calculator, that internal API, maybe reading a file. You define the tools, the model decides when to use them. The tool runs, the results come back, and here's the key. Using Strands and letting the model define that orchestration, the model can reflect, do I have enough information? How do these results change my understanding? Should I continue, or do I just provide the answer with the information I have? That loop, reason, act, reflect, that's what makes this agentic. And that is the React pattern. And it's at the core of Strands. You didn't write the orchestration logic. You didn't define the state machines or chains. The model handles it, and that's what model-driven means. When an API call fails, the model doesn't crash. It reasons about alternatives. When a user asks something unexpected, it doesn't follow a predetermined, I don't understand path. It figures out how to help using the available tools. Let me make this concrete. On the left, this is what building agents could look like today, right? You define the workflow, you're defining these transitions, you are the orchestrator. And that works until the model gets smarter than your own orchestration, where it can hold you back. You pick a model provider on day one, and then your entire code base could be potentially coupled to that. And then months later, when a better model drops, maybe even from a different provider, you end up needing to rewrite the code. And something wrong is going to go wrong in production. So say your agent hallucinated, it called the wrong tool, or it's looping forever. Why? Good luck. You're struggling to figure out what happened. And that production gap is real, right? The thing that worked on your laptop with that prompt, it's not surviving the real traffic and real users who type things that you would never expect. And so this is where Strands can flip some of that. You didn't write the orchestration. The model is the orchestrator. It reasons about what to do, picks the tools, reflects on the results. You define the what, and the model figures out the how. Model provider, you can swap that with one line of code. I'll do that in one of the live demos here shortly. Your tools don't change, your prompts don't change, your tests don't change. Say today you're working with Claude, tomorrow you're working with Nova, the next day you're using a local LLM like Olama, all with one line of code changed. Observability is built in, so every iteration, every tool call, every reasoning step, you can see it. So when your agent does something wrong at 2 a.m., you don't guess, you can trace it. And production isn't just theoretical. Amazon systems, including AWS products available to you today, are being built on Strands. And let's take a look at this list. These aren't just supported, like Anthropic contributed, right, to this code base. There's been contributions from Meta and these other companies like OpenAI, Writer, they all contributed code. So the community has showed up. Hundreds of pull requests merge, many coming from outside Amazon. So this is not just an AWS SDK with the community label slapped on, it's actual open source. All right, let me prove it. Let's build an agent. All right, so I'm gonna try to blow this up so y'all can see it. Is that legible in the back? I'm going to have white text be what we're looking at, so I think it's gonna be okay. You don't need to look at the shell. Yeah, I'm bumping it up on my screen. It's about as bumped up as we can get it. Okay, cool, awesome. So just to show you that, right, I'm gonna show you, that's pretty legible, hopefully. Yes, awesome. So this is I'm just got a simple shell script here, which is gonna activate Python virtual environment and install Strands. So I'm not even gonna use AI for this. We're gonna write this stuff or use this stuff all from scratch. Hopefully that's very legible, excellent. All right, so this is the code. Let's go ahead and run that here. I need to use source to activate the environment and start pulling down the dependencies. Cool, that's working, internet's working, that's live demos going okay so far. All right, so now we're gonna open up my first agent. And yes, I'm gonna make that bigger for us. And we're gonna see how easy, again, this, folks, is a simple demo. I'm showing the foundations of working with Strands. So we're gonna build our first agent in 3 lines of code. In fact, the agent itself is only 1 line of code. It's that agent definition on the second line. The last line of code is where we're invoking the agent and we're gonna give it a prompt. So for the prompt, I'm going to say something like, isn't Raleigh NC a great place for a tech conference? Cool, I'm gonna save that. And there is a question you may have, like what LLM is going on here? What inference is happening? So Strands by default is gonna use my AWS credentials to run inference on the Amazon Web Services inference service called Amazon Bedrock. So if you wanna run LLMs on AWS, you typically are gonna use Bedrock. Again, you can use anything you want. You could actually use Anthropic or OpenAI keys directly. For this demo, I just happen to be using the default here, and so I'm gonna let that go ahead and cook. By default, it is Anthropic Claude. All right, so we saved this. Let's go ahead and run our first agent. Cool, let's see what Claude has to say about Raleigh being a good spot for a tech conference. All right, cool, we're getting some colorful things from Claude, even a shout out for All Things Open, that's exciting. All right, cool, NC State, go Pack. I'm an NC State computer science grad, love to see it. All right, so cool, we get a nice response there, we built our first agent. All right, let's go back to our deck and think about how to expand this, right? Like, let's be real, we gotta add things like tools and everything else. So we're gonna go one step further and add a custom tool. All right, so I'm gonna exit out of here, go back to our shell, and we are going to run our second agent here in a moment. Let's walk through that code. So for this code, I'd love for y'all to gaze your eyes at the very end, the very last line of code here. This is our agent invocation. So this line of code is how we invoke our agent. All the other code above this in Python here is how we're defining the agent in strands. So we're going to ask this agent, what's the weather? Let's take a look at how we define the agent. So we have this agent equals agent, just like in the other simple agent Python code. This time we're going to give it a tool parameter and tell it that, hey, we're creating you, you're an agent, and you have access to a weather tool. And the system prompt we're going to use for this is very ambiguous. We're basically just saying, you're a helpful agent. Use your knowledge to invoke the tools directly yourself. So we are giving it a little nudge here in the prompt saying, hey, you might have access to tools, so check that out, and use knowledge, if you got it, to invoke it. So if we look at the definition of the weather function here, you'll see I have a tool decorator, and the weather function is simple. It takes in a latitude and longitude. It calls this free API. It's just making an HTTP request, passes in the lat and long, and gets back some JSON. So you see I'm importing some libraries for HTTP requests and JSON interpretation. And then I'm going to return simply a temperature in Fahrenheit and Celsius. So this function, we've given it a tool decorator. And the function itself only accepts this latitude and longitude and returns a temperature. If you know here, when we invoke this agent, right, we're using strands. It's going to use Claude here because we're not specifying a different model. We're just giving it Raleigh as the context. So you're going to see that reason, act, reflect in action right now. So I'm going to run this, and you can see here it identifies Raleigh. It sees that it has access to a tool. It's going to go, I'm smart. I'm a model. I know how to invoke tools. To invoke the tool, what do I need? A latitude and longitude. And it infers that from its knowledge base to infer the latitude and longitude to pass into the function to use the tool. And it's nice and chilly, so folks traveling out of town, it could be a heater today, so I'm digging the weather myself. All right, so let's go back to our deck and see what we have next. All right, we're talking more about tools, right? So you saw the tool decorator. That's a simple way, but Strands gives you additional ways to add tools. So we have first-class support for MCP. I hope everyone here is familiar with multi-context protocol. It's a simple way to augment agents or AI coding tools with additional resources, additional tools and context to deliver the outcomes that you're looking to get. So MCP is great. Additionally, we have pre-built tools. So I'm going to demonstrate some of that next, right? We're going to use one of the pre-built tools to kind of show you how you can take advantage of some of that and do an actual real-world potential DevOps use case. And another thing that's pretty wild is one internal agent. This is something I wasn't approved to say. One internal AWS agent has over 6,000 tools. And it's difficult for models to actually, I think in Steven's open space earlier, someone was asking about, hey, MCP, it's going to use a lot of tokens and that sort of thing. So just thinking about how advanced architecture, so in this case, they're using semantic search to then optimize how you're selecting tools. All right, so I think we're ready for another demo here. And I'm going to do, again, I'm emphasizing there's production stories here at Amazon, but I'm showing you these foundations to give you inspiration of what's possible with Strands. So we're going to go back to our first agent. We're going to run that in a moment. But first, we're going to, again, I really am dependent on AI to write my code these days. So yes, thank you, Nirmal. I need to exit out of the PowerPoint. Here we go. We're back in the editor. Yes, you can see it. That's awesome. All right, so I'm going to attempt to write code manually here. So moonshot AI.kimi k2.5. Anyone heard of Kimi? Anyone using Kimi? Y'all should be. It's amazing. It's super cost effective and super good for what it is. So we're going to see what Kimi has to say about Raleigh. Assuming I implemented this correctly. Let's find out. The suspense is building. Kimi is really, really fast, so I think it's a network latency. All right, now it's coming out. All right, there we go. Wow, Kimi has a lot to say. Okay, all right. So cool, another shout out for NC State, love to see it. Wow, the craft breweries galore. Okay, interesting. Oh, wow. Recent Amazon office. Okay, that's very good to hear. All right, love it, Kimi. Okay, cool. So you can see, and again, just to prove this is a real demo, I'm just gonna go ahead and invoke this again to see what other thoughts Kimi might run, because LLMs, as we know, are non-deterministic, and we're never gonna get the same exact response. So here we get no mention of the breweries, and I don't see Amazon anymore. So very cool. All right, so let's go back to, okay, so that's an example of swapping the model. So how easy it was to swap the model, right, is one line of code. Let's go and open up, let's do our DevOps use case, DevOps-ish use case. This is something that I work a lot with students and early career cloud people, and people just getting into the cloud for the first time, they follow tutorials, they learn things like, oh, I need to set up VPC and get my EC2, and NAT gateways are a way for that network thing to work, and they cost money. It costs about $30 a month. So for a student, if you don't need that NAT gateway after you set up your tutorial, you should probably delete it. So I'm actually gonna get this agent here using a built-in tool. So I'm gonna say use AWS. So this is just a built-in AWS tooling. I'm gonna give it a system prompt as you're a cost detective. So it's a generic prompt for this agent of, hey, just help me look for things to save money. We always want to reduce our cloud costs. And I'm gonna ask it specifically about my NAT gateways. So here we go. My third agent now, right? Oh, okay, now y'all really know this is a live demo. Okay, so we got an error message. I'm missing Strand's tools. Okay, let me see my setup. Yeah, I need to install a dependency here, y'all, so bear with me. So I'm giving it this, I missed this dependency for the tools, so I'm just giving it Strand's agents tools, and then I'm gonna save that, and then I'm gonna run source again to pull down the dependencies for tools. Okay, cool. So once this downloads, I'm going to be able to run our cost detective agent. I'm specifically going to ask it about NAT gateways. Let's see what it has to say. Cool. Well, it's invoking tools. It looks like, I'm guessing right now behind the scenes, it's checking a bunch of different regions for NAT gateways. So that's why it's repeatedly showing up as tools. And there we go. Looks like we have some NAT gateways running. Okay, so one of these, okay, this one I definitely set up for my DevOpsDays 2022 talk, and it's still running. I should probably delete that. But yeah, as you see, these costs can add up. So there we go, we have a cost detective. Imagine how you can do really cool things with some of the built-in tooling and production type use cases. All right, so we're going back to our presentation. So y'all care about what happens after this demo, right? So let me talk about the production story, observability. So Strands has open telemetry built in. So every agent loop iteration, every tool call, every model invocation, it's all traced. So when your agent does something unexpected at 2 a.m., you can see exactly why. Session management. Your agent can persist in full conversation. It can persist a full conversation history. So you can do this easily with S3 if you're using AWS, or you can run it on any storage backend. So imagine the scenario where you restart your container. You want to be able to have the agent pick up where it left off. Guardrails. And when we talk about production, customer-facing systems, guardrails are really, really important. I was talking to someone else earlier today, and they are doing stuff with hospitals and require HIPAA compliance and all this. So these are all good things to keep in mind. The agent control lets you define what your agents can do and can't do at runtime without changing any agent code. So think of like PII redaction, content filtering, or tool restriction. And finally, I want to emphasize the ability to deploy anywhere, right? AWS pays me, I'm biased for AWS. If you ask me where to run my strands, I'm gonna tell you, hey, you might consider Amazon Bedrock Agent Core. It's a serverless, fully managed runtime for agents. But you can run on any cloud. You can run on-prem. You can just plug Olama on your local system and run it right on your own computer. It doesn't even have to leave the network. I think that's really cool. So this isn't just a side project, y'all. This is thousands of GitHub stars, tons of community pull requests merge. It's real open source community. So let me give you the mental model that you're gonna take home. One, the foundation of an incredibly powerful agent can be as simple as 3 things: model, tools, and a prompt. The model drives its own behavior through that agentic loop. Reason, act, reflect. 2, tools are how you customize. As you saw me use the @tool decorator in my Python function, prime example. MCP servers as well, right? You can throw in MCP, you can use the pre-built tools as you saw in the demo. Start with one function and then scale from there. Let the model decide when to use the tools. 3, it's simple to start and you can get to production when you're ready. 3 lines for just some basic working agent. You can add more prompts that guide behavior. You can swap models. You can persist storage with, like, for example, S3 or whatever storage solution, add those guardrails, and deploy anywhere without having to rebuild the agent. So now that you've got a mental model, agent equals model plus tools plus prompt, what might you actually build with this? So I was talking to Nirmal at the speaker dinner, and he advised throwing up some use cases. So thank you for this one, Nirmal. These might be some cool use cases for y'all to think about in the DevOps space. Incident response. Alert fires at 2 a.m. Instead of you pulling the logs, checking what deployed, correlating metrics, let the agent do it. You can build your own agent to do this. You're paged at 2 a.m. Imagine by the time you pull out your laptop, you already have a draft root cause analysis for you to dig in. Infrastructure drift. Another topic that came up at that dinner, right? Terraform says one thing and then some folks are doing some other things, right? And I know that there are tools out there to do this, but imagine if you wanted to build your own thing. An agent reads a state file, compares it against reality, tells you what drifted, whether it's safe or not to fix. No more quarterly drift audits that we know actually don't happen. Runbook automation. So you've got runbooks, everybody does. Nobody likes executing them manually during an incident. So an agent could read the doc, execute the steps, and pause for your approval before anything destructive. To echo Seth's point, like, we don't automate all the remediation things necessarily, right? We want some human in the loop sometimes. And then each of these are things you could build with Strands with just some tools and a prompt. You could even prototype this kind of thing, any of these things this weekend. So here's what you're gonna do today. You're gonna set up Strands, you're gonna keep it simple. At first, you get a working agent, you're gonna add a tool and let the model decide when to use it. And then you can push it further, add a system prompt, swap the model, connect an MCP server, see how far you can go without rewriting anything. Go ahead, you can take a picture of this. We recently launched a Discord community for Strands builders. So when you go out there and build with Strands, if you've got questions, of course you can reach out to me directly, but for the Discord, there's experts way deeper than Strands, way deeper with Strands than me that are hanging out there all the time. So definitely feel free to take advantage of that. The docs are at strandsagents.com. The GitHub is under Strands Agent. Apache 2.0, it's yours. Every agent demo works once. The question is, what happens when the requirements change, when you need to swap a model, when you need to debug at 2 a.m., when you need to ship to production? Strands was built for that moment. And we kept it really basic today to inspire you on the possibilities with Strands. So I'd love for you to connect with me to keep the conversation going. I'd love to see you at any of these events coming up next week. In the bottom right, if you're in town, Blackson Tech RDU is hosting us for a free workshop. This will be getting hands-on with Kiro, our agentic IDE. This event is free. Everybody's welcome to sign up. It's at 5 o'clock on Monday. And then on Wednesday, May 6th, there's another tech conference. It's free, Agentic AI. So if folks are geeking out over this agentic stuff, consider, if you're free, to join us on Wednesday at AgentCon. I'm giving a similar talk at AgentCon, except I have more time, so that means more live demos. So, but I also know Mark, who organizes All Things AI, is speaking at the same time, and he's doing a talk on building an agent in 90 minutes. So if you're looking for some variety, some more inspiration on building agents, definitely consider attending Mark's talk instead of mine. And finally, feedback is super important. So as a developer advocate, I love dialing in on how we can improve developer experiences at AWS. A big part of my job is influencing our product teams to make the developer experience better for everyone. So as you explore Strands, Kiro, anything related to AWS, when there's things we can do better, please tell me. I'm committed to taking that feedback directly to the product team. That's my job. Go to my website, you'll find my LinkedIn. Reach out to me with any feedback. Please take 1 minute. I know they're about to kick me off stage. Please take 1 minute to scan this QR code. It's one question. It's gonna ask you if this was good or bad. Please give me your honest feedback. I genuinely will look at this information. It's anonymous, and use that to improve these kind of things for the future. There's an optional text field for you to share any other general thoughts you have. Anything goes there. Thank you, the DevOps Days organizers, NC State, and the staff for putting this together. And all of you, you are the community, you are DevOps Days, and thanks for making the time. Y'all are amazing. Looking forward to hearing what you build with Strands.